Hi everyone, so now let's look at the final examinations for semester 1 session 2022 and 2023. Okay, so we have tried this question 1A in our tutorial sections and question 1B also in our tutorial sections. Okay, so maybe for section 1 it is not complete because we continue in section 2. Okay, so the full solution for question B is you can find it in the notes of section 2, and also this question 2 also. Okay, question 2A and 2B I have tried it, okay, with section 2. You can refer to the notes. Okay, so now I would like to talk about the question C. Okay, question C. So you have a cone and a sphere and they are given by these two equations. Okay, these two equations. So you have to sketch the 3D graph, okay, of a solid bounded below the cone and inside the sphere and its projection to suitable plane. Okay, and next calculate the volume of the solid, okay, bounded below the cone and inside the sphere by using the triple integrals. Okay, so let's go to the solutions. Okay, so this is questions 2C. Oops, question 2C. Alright, question 2C. So let me write down the equation for the cone. So for the cone, it is these equations. And then for the sphere, it is z. Okay, maybe I write in this way. X squared plus y squared plus z squared equals to 6z. Okay, so let's draw these two solid 3D graph, okay, together. Okay, first of all, we look at the equation for the sphere. So the normal equation, the common equation of the sphere should be like this, right? If you still remember. Okay, so it will be r squared, something like this. Okay, so the r over here represent the radius, okay, of the sphere, right? So in this case, okay, our right side is not just a number, so it has a variable z. Okay, so we have to use the technique of completing the square in order to find the center of the sphere. Okay, so if the center of the sphere is at the origin, here you will see a number, but here it is not a number. Okay, so what I will do is I will just write it here: x squared plus y squared plus z squared and minus 6z equals to 0. Okay, 6z equals to 0. So I can perform the technique completing the square. So x squared plus y squared plus, okay, so this one you can write it as z minus 3 square, okay, and minus 9, okay, equals to 0. Okay, so now if you move the 9 to the right side, okay, so you will get these equations equals to 9. Okay, so the 9 over here, okay, represent the radius of the sphere. No, it's so the radius of the sphere will be 3 square. Okay, so the radius will be 3. Okay, so now you can start draw this sphere. So you can draw this sphere. Okay, so one thing that you have to take note is where is the center of the sphere. Okay, so the center of the sphere you can refer to the equations. Okay, so for the x is 0, the y is also 0, and the z it will be 3. Okay, positive 3. Okay, and the radius is 3. So you can draw like this. So let me draw it out. Okay, draw this thing. Okay, something like this. So this is the center, 0, 0, 3. Okay, and the radius will be 3. Okay, will be 3. Right, so this is a sphere. Next, we have to draw the cone. Okay, we draw the cone. Okay, so this is just a common cone, and we have drawn it so many times. Okay, so this is the cone. So we draw the cone. Right. Okay, so we have overlapped these two 3D graphs together. Okay, so we have to read back our questions. Okay, the question says that, okay, the solid is bounded below the cone. Okay, so means that the solid, okay, the bottom, okay, or the bottom of the solid is bounded by the cone and it is inside the sphere. Okay, so I will select this region. Okay, I will select this region, okay, to represent my solid. Okay, to represent our solid. Okay, so you must shade this one, okay, to tell us that, okay, that you understand that where is the solid. Okay, so you have sketched the 3D graph. Now you need to sketch the projections. Okay, projections. So you can sketch the XY projections. So XY projections, you can sketch the XY projections. Okay, so obviously the XY projection, you can see a sphere. Okay, you can see a sphere, right? Okay, you ignore this part, okay, you ignore the side part, okay, because you just want to look at the section that has been shaded by the red line. Okay, so if you draw the 2D or XY projections, okay, so you will see this shape. Am I right? So this is the shape that you will see. Okay, so the shape, right? Okay, so any idea about what is the radius? What is the radius here? What is the radius here? Okay, so the radius here would be, okay, 3. Okay, it will be this one. Okay, the 3. It would be 3. Yeah, it would be 3. The Z is 0. Right, okay. So this is your XY projections. Okay, XY projections. Right, so we have completed the question number 1. So we go to question number 2, which is to find the volume by using the triple integral. So volume, we can solve by using triple integrals, right, dv. So the first question would be, okay, what coordinate system you want to use? Okay, so we have tried similar questions in our class. Okay, so for this kind of structure, we are going to solve by using the spherical coordinate system. Okay, so for spherical coordinate system, it will be rho square sine phi d rho d phi and d theta. Okay, so this one will be our equations. Okay, so now we need to define the d rho, d phi and d theta. So we look at the structures. So rho, okay, is the value from here until here. Okay, so for all the point here, they will have a different rho values. Okay, and depend on the angles over here. Depends on the angles over here. So in order to get this thing, okay, to get the value, okay, of the rho, so you have to take the equations of the sphere, okay, which is this one. Z squared equals to 6z. Okay, so this part you can convert it to the rho square, and this one you convert it to 6 rho cos phi. Okay, so this one is a transformation. Okay, so you can write it as 6 cos phi. Okay, so the value, okay, the interval of your rho will be from 0 until 6 cos phi. Okay, now for the phi, d phi, remember I told you before, if the equation of the cone is equals to x squared plus y squared square root, okay, if the equation of the cone, the phi will be pi over 4. Okay, so there are steps, okay, to show that how the phi to be pi over 4. You can refer back to the module, okay, you can refer back to the module. And for the d theta, okay, it will be from 0 to 2 pi. This one you can find out from the xy projections, okay, because it is a complete circle. Okay, so from 0 to 2 pi. So let's go to the solutions. So 0 to 2 pi, okay, 0 to pi over 4, and 0.6 cos phi 1. Okay, rho square, okay, and sine phi d rho, okay, d phi and d theta. Okay, so we are going to solve this. Okay, we are going to solve this thing now. Right, so the first one we have to solve manually. Okay, because we have a variable there, 4. So it will become rho square, rho cube, rho cube over 3, and you can replace 6 cos phi 0 into it, and you have a sine phi, d phi, and d theta. Okay, so you can take out the 1 over 3, right, because it's a constant, pi over 4. So this one will become 6 power 3 cos power 3 phi and sine phi d phi and d theta. Right, so for this one, now you can press calculator. You can take out the 6 power 3. So you integrate the cos, okay, phi cube, okay, multiply with the sine cube, okay, then is pi over 4 and 0. So the 6 I take out, okay, over 3. So 0 2 pi, this is 2 pi, okay, 0, oh no, this one complete already. Okay, so you will get 3 over 16. Okay, 3 over 16, 3 over 16, and d theta. Okay, so now you just put them together, 3, then you have a 3 over 16. Okay, then you have a 2 pi. Okay, so let's see what is the answer. 6 power 3, 3, 2, oops. Okay, so you get 27 pi. Okay, so you can put unit cube. Okay, so this is the volume of this solid. Alright, okay, thank you class.